we will talk about the module Get Informed. It's not a tool, but it's a module, and it just has the general information about this solar-powered information irrigation. And this doesn't work again. No. If you look at the Get Informed module, you see it has 10 short chapters about an overview about the solar generator, about the mounting structure, the controller and inverter, the water pump monitoring system, reservoir, irrigation head, fertigation, irrigation system, more or less what we have been seeing now with the photos you have seen. And I just want to take a few slides. We have seen yesterday solar radiation, the sun is not constant, moves. And so my question to you is, how much do you incline the solar panels, let's say with Victor and Anna? I think we have the, how much do you take the inclination?
¿Cuál sería la inclinación en el área de Coquimbo? No sé la latitud.
Yeah.
30 o 27, 28.
You have to know the latitude, and usually you say -10. For example, if you are close to the equator, you still take 10 degrees at least, that when it rains, that it washes the dust away. You never put it
horizontal.
Directly horizontal. So this is, and we saw that in the southern hemisphere we put it directly to the north, and like in Germany, my system would be directly to the south. And yesterday we talked about lifespan. I mean, I installed my system in '91, so it's 26 years old. The panels are in perfect condition, and they say, sometimes they say 1-2% will be less every year, but I haven't, almost none, no decrease in power for 26 years. So, just to tell you, I mean, these systems last long. Now you see also in Arica, where is if you would put the panel horizontal, you would get a curve around the year like this. And you see here you start with 7.5 kilowatt hours per square meter, which is, I think, one of the highest in the world. I mean, in Germany, for example, we have longer sunshine hours during the summer, but we would not get more than 5.5 maybe. So this is, and then in this case, if you incline it, you see that you get a more even, I mean, not so in winter, but you get a more even curve during the year. And maybe a little bit about the specifications you saw yesterday. They all have more or less the same standardized code. You see, LC stands for the manufacturer. So you can look in the internet. I mean, they more or less come all from China. 250 is the watt peak we saw yesterday. P is polycrystalline, and 60 are the 60 cells. If you look at this, 1, 2, 3, 4, 5, 6 times 10, 60 cells. So if you look at every panel on the back, you can see quite clearly they have and I'll show you in a minute what we saw yesterday. They all have this label. And yesterday we learned that this number, watt peak, the watt peak is for standard test conditions. That means for insulation of 1000 watt per square meter at 50 to 25 centigrade cell temperature. And we see there is P for polycrystalline or mono for monocrystalline, and you see how many cells. And yesterday, in the last place where we were, I took this picture, and you see it's HR, and here they even have given their own name. It's Chinese company, 310 watts. P is for polycrystalline, and in this case, it has 24 more cells. This was the big plant where we are.
La segunda.
Yeah. And here they also give you, okay, the 310, but they tell you that their tolerance is, that maybe it's even 5 watt more. And if you don't have any load on it, you get 36 volts. And if you put it in short circuit, you get 9.1 ampere. If it works at maximum power point, we'll talk about this later, you get 8.42 amps. So this you have on every panel, you have on the back. So it's quite easy to know what is the maximum power it can produce, depending also on the insolation or irradiation, what we talked about yesterday, and the temperature, the ambient temperature. And yesterday also we talked about shading, and especially in areas like here, you have to see that there's a big difference between summer and winter. So if you have the trees here, and when you see in the summer the shade is here, so you think here I can put my panels, but then as it goes to autumn or winter, you see that it will be shaded. I was a few months ago, I was in Kenya, and I visited a farmer, and he said the solar pump is very nice, but at 2 o'clock it always stops. So I said, let's look. So the sun after 2 o'clock, there was shade by trees, so it was very clear that it was not installed correctly. And he thought it's a problem with the pump or whatever, but it was very easy. So we will just a general overview. We see that if we don't have a tank, we do direct pumping from a well, or here from surface water, and it goes directly to the irrigation system. But as we said, it's cheaper, but it has some problems because the amount of water will vary with the sun. So, and even if clouds are coming and going, so it changes. If you have an open irrigation, it's not as bad as if you have drip, for example, then you might have more problems. So in this case, we have a well and we pump into a reservoir. So we have defined head now for the irrigation system. And we'll see for drip irrigation we need at least 5 meters, 0.5 bars. So this usually can work, but this reservoir or tank is a cost factor. But if I have a slope, maybe I can get around these tanks with the high elevation. And here you see there is fertigation, meaning I put fertilizer or other chemicals. We talk about irrigation into the irrigation water, but we also can put fertilizer, what have you. We saw before the controller. This is the picture from yesterday. Unfortunately, we don't see this. This was at the first place where we were. I think it was, how much was it? 250, 240. Yeah. The controller is the very important part. I was talking to manufacturers and they say, look, the pumps are more or less developed, but this pump manufacturer where I was, they had 60 people, only software engineers and electronic engineers to more or less make these controllers more efficient and more combined with the solar power generators. So that, for example, in the morning when the sun rises, the pump will start, but then will maybe stop because it's just about to start, but then it's not enough. So it starts, then it draws more power, then it stops. These things you can all do with these controllers. And even in small systems now, you have sensors anyway for the water in the well, because you don't want that your pump runs dry, because then the pump will be very fast gone. So now it's getting more and more cheap and easy to connect it with a transmitter so that you can read and get your data from the pump in wherever you are on your smartphone. I mean, there's more and more that they now can control the water table in a big area where you have controllers with these devices that you can see on your smartphone or on the computer, on the internet. You see how they work. And this was before only for very big systems. In the meantime, even small systems, 1 kilowatt at low, have quite a number have already these possibilities. If we come to irrigation, we see that flood irrigation is maybe less efficient, but you don't need so much head. But if you pump with such a more or less expensive device, you would not use flood irrigation, but on open channels, but maybe low pressure drip. Typical head, they say 1 to 10 meters, 5 meters, I think is an average figure you can use. You see that with sprinklers, you need higher head, and I mean, okay, we saw yesterday, for example, I mean, it was not sprinklers, but the head was not enough for the strawberries, so he had another pump. I mean, the idea is to avoid this, to have the costs come down. Okay, high pressure irrigation you would not use with solar systems. I mean, this is just a small overview which you get from the Get Informed, which gives you just a broad picture. I talk now much. Is there any questions? Is there? Everything totally clear?
Yeah.
You saw the difference between this direct pumping and pumping with storage, which is quite an issue with solar pumping, and it depends very much on the situation. If you already have a tank or not, how much the tank would cost if you have a very flat area. Or you want to say something?
No, pero hacer una pregunta en español también y lo vamos a...
I want to make a question. The controller, is possible to receive the signal for a wind energy and solar energy simultaneously?
This the controller gets its power from the panels.
Yes, but the controller, I see the control. This control we can use for wind energy and two with photovoltaic solar energy.
Yeah.
My question is possible that I can use a wind system and a photovoltaic solar system simultaneously?
You can use, but I don't know if this controller would be, because this controller is for the ESCO-Flex, for the Grundfos. But there's controllers where you can put them all together. In this case, I think it's only thought for one of them together with a pump. But there's controllers that usually all these big companies, they have their own controller, and they say if you use their pump with another controller, they don't give you any guarantee anymore. So, okay, on the one hand, they want that you use their system, but it's optimized. I told you before that this software is getting more and more important, so they optimize, and they usually have a higher efficiency. That usually they have definitely a higher efficiency if you use the whole string of controller, solar generator and pump. But it's also more expensive. So, and what we discussed before, I mean, if you use from one big company, you also look, do they have a representation near you? If in case there would be something, you have somebody who can help you. Otherwise, if you use from different parts, it might be difficult. Yeah? If you use a pump here and from people who would only sell but don't give you an after sales, what we call after sales service, then it's much more difficult.
Me imagino que esta pregunta es interesante para los participantes, ¿no? ¿Dónde comprar estas cosas y cómo es la reputación de cada empresa? Y cómo saber cómo comprar buenos componentes, ¿no?
Look, for example, I talked to the farmer yesterday, to the first farmer, and he says the plant now is 4 years old. I never had any problems. I talked to many farmers in other countries. They say, oh, after half a year, it burned, so I had to call the people. They had to repair it, and then after another year, this happened. I mean, we talk now a lot about what we say life cycle cost. We look, I mean, we say the pedals last 20 years at least, 25 years. What are the costs in these 25 years? If the pump lasts for 10 or 15 years, you calculate, or if I have a pump that lasts for 4 or 5 years, and I have to buy 4 or 5 pumps in these 25 years, or I have to buy just 2, or maybe even 1. I mean, this is this also we will see in the end with this financial viability too. Okay, so this module 3 is safeguard water, which I just want to show you before I go to the tool briefly what we see. I mean, this is the original module which you see when you download it. See, there is some disclaimers which you are not interested, some abbreviations, and here you have again the table of content, understanding groundwater, analyze the water management and regulation, analyze water extraction, explore cooperative water governance, review potential risks, impacts, and adjust planning. I mean, the biggest disadvantage of solar pumping is that you might overpump. If you have a diesel pump, you always try to save your diesel, so you pump not more than you need. If there's a solar pump, you once have the pump, you leave it on even if you don't need water. I mean, most people would switch it off, but still there's a danger. You might have heard in India, there's big groundwater problems. They have lowered the water table 100 meters and more in some places. So they usually, these pumps, they have are grid connected, so these farmers get only power 4 hours at night, so that they don't pump too much. But now if they start to buy solar pumps, nobody can control them anymore. So this is the big danger. That's why I think this water part is quite important for us, and we have to prove that we really don't overpump the aquifer.